Hi, I'm Ben, and today we're going to work on different ways to visualize data. Our objectives today are to work with one variable data, then we're going to work with two variable data, we're going to look at the distance formula, and finally the midpoint formula. So let's start off with an example. For the given table, complete the following. A, plot the numbers on a number line, then B, find the maximum and the minimum values in the data, and then C, determine the mean of the data. Well, let's start by plotting the numbers on the number line. We have -10, 20, 30, -20, 0, and 10. So let's draw a number line. -20 is the lowest number, so it'll be here. Then we have -10, 0, 10, 20, and 30. So that's A. We've plotted these numbers on the number line. Now we want to find the max and the min of the data. Well, the min is going to be the number furthest to the left. So our minimum value is -20. The maximum value is the value furthest to the right. That's 30. -20 is the min, 30 is the max. Now what's the mean of the data? To find the mean, we need to find the average. So let's take -10, add 20, add 30, and then subtract 20, add 0, and then add 10. Well, the plus 20 and the minus 20 will cancel out. The plus 10 and the minus 10 cancel out. So we're left with 30 plus 0 is 30. Now, how many numbers did we have to begin with? 1, 2, 3, 4, 5, 6. So we take our sum of 30 and divide by 6. That gives us 5. So the mean of this data is 5. This is the mean. Now the median of a sorted list is equal to the value that is located in the middle of the list. If there's an odd number of data items, then the median is the middle data item. If there's an even number of data items, the median is the average of two middle items. So focus on this here. An odd number of data items, the median then is the middle data item. But if there's an even number, the median is the average of the two middle items. The range of a data list is the difference between the maximum and the minimum values. So, take your number line, find your max value here, you have your min value here, and the range is equal to max minus min. So let's try out a problem using these concepts. If the monthly average precipitation in inches for Seattle is 5.7, 4.2, 3.7, 2.4, 1.7, 1.4, 0.8, 1.1, 1.9, 3.5, 5.9, and 5.9, we want to A, sort these data in increasing order and display them with a table. So start from smallest and go to largest. Find the median in the range of this data set, and then interpret the median in the range. So I've rewritten all these numbers for us, and we need to put them in order. Well, let's first examine the units place, the number right before the decimal. There's a 5 there, a 4 there, 3, 2, 1, 1. Here's a 0, and that's the only 0 we have. So we know this is going to be the lowest value. So let's start with 0.8 and cross that out. So now let's look for all the 1s. 5, 4, 3, 2. Okay, here's 1.7, 1.4, 1.1, and 1.9. So let's examine the tenths place, the number to the right of the decimal. Here's a 1, a 9, a 7, and a 4. So let's put those in order from smallest to largest. 1's the smallest, so it's 1.1. Then 4 is next, so 1.4. Then here's 1.9 and 1.7, so it's 1.7 next. And then lastly, 1.9. So that takes care of the zeros and the ones. Now let's look for the 2's. Here's 2.4, and that's our only 2 value. So 2.4 is next. Look for the 3's next. 3.5 and 3.7. 5 is smaller than 7 in the tenths place, so 3.5, then 3.7. Then we look for 4's. 4.2 is the only one there. Now we're looking for the 5's. Here's 5.7, 5.9, and 5.9. So we're going to say 5.7, and then 5.9, and 5.9. So that's A. We've sorted these out in increasing order, and we can display them in a table by just boxing it in, and we have a table. So B, find the median and the range. Well, do we have an even or an odd number of values here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, we have 12. We have an even number of values. So remember, the median, in this instance, we have an even number of values, will be the average of the 2 middle values. So we have 12. We're looking for number 1, 2, 3, 4, 5, 6, and 7. We need to average 2.4 and 3.5. So to do that, 2.4 plus 3.5, that gives us 9 there, 5 there. So 5.9. Now divide that by 2. That's going to be 2.95. Just do it this way if you need to. 5.9 like that. 2 there. 2 times 2 is 4. 5 minus 4 is 1. Then 2 goes into 19 9 times there. And then there's a 1 there. 5 like that. So 2.95. That's the median. Now what's the range? Remember, to find the range, we take our maximum value and subtract the minimum value. What's the maximum value here? The max is 5.9. The min is 0.8. So the range is 5.9 minus 0.8. Subtract that, and you get 5.1. So that's the range. Now we need to interpret the median and the range. Remember, our median was 2.95. So what that means is 6 months of the year it rained more than 2.95, and the other 6 months of the year it rained less than 2.95 inches. That's what median tells you. Half is greater than this, half is less than this. The range tells you something different. It tells you that the precipitation, or the amount of precipitation, varied from month to month by up to 5.1 inches. The rainiest month rained 5.1 inches more than the least rainy month. Now we need to look at relations. Relations have a specific definition in math. A relation is a set of ordered pairs, often denoted x comma y. The set of all x values is called the domain, and the set of all y values is called the range. So when we talk about the set of all x values, we're talking about all the possible values of that x right there. And we talk about the set of all y values, we're interested in that y right there. And the relation is the set of these different xy pairs. So let's try a problem. For this relation here, 2 comma 2, negative 3 comma 1, negative 4 comma negative 1, negative 1 comma 3, and 0 comma negative 2, complete the following. Find the domain and the range of the relation. Determine the maximum and the minimum values of the x values and of the y values, and then plot the relation by hand in the xy plane. Let's start with A, domain and range of the relation. Remember, domain is all the possible x values. So let's look at the ordered pairs and find the x values. Here's a 2. This is the set of all x such that x is equal to 2, -3, -4, -1, and 0. And we put them in brackets like that. And then the range is all possible y values. And that's going to be where y is equal to 2, 1, -1, 3, or -2. So that's the domain and the range. Determine the maximum and minimum values of the x and the y's. Well, let's look for our largest x. Here's a +2, negative, 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 0. So the max value of x is the only positive one, the 2. So the max x is 2. What's the minimum value of x? Well, it's going to be a negative number. There's -3, -4, and -1. -4 is the smallest number. So the min for x is -4. How about for y? Let's look for the max. 2, 1, -3, negative. Well, the biggest y is 3 there. So the max value of y is equal to 3. How about the minimum value of y? 2, 1, there's a -1, 3, and a -2. -2 is our smallest value. So the min of y is -2. So now we need to plot these relations by hand on the xy plane. Well, here we have the xy plane. The first thing we're looking for is 2, 2. So we count 2 to the right and 2 up, and we get this point right here, 2, 2. Then -3, 1. 1, 2, 3 to the left because it's negative. 1 up because it's positive. We get that point right there. -3, 1. -4, -1. 4 to the left. 1, 2, 3, 4. And down 1. -4, -1. -1, 3. -1, so 1 to the left. +3. 1, 2, 3 up. That point there, -1, 3. And then lastly, 0, -2. We don't move at all to the right or the left. And down 2 is this point here, 0, -2. So those are all the relations plotted by hand on the xy plane. Let's move on to a couple of formulas related to relations in graphs. The distance formula here. The distance, d, between the points x1 and y1 and x2 and y2 in the xy plane is given by this formula. D is equal to the square root of this huge quantity here. And remember, all of this is under the square root sign, underneath the radical. What we're interested in is x2 minus x1 squared plus y2 minus y1 squared. And remember, because of the commutative property, you can actually switch the y's and the x's around and do y's first and then x's. Just don't get too upset if you do them out of order. Just make sure that you're consistent, x2 minus x1 and then y2 minus y1. Consistency is pretty important. So this is the distance formula. That's going to give us the distance between any 2 points on the xy plane. There's another formula that we're interested in. That's the midpoint formula. That'll tell you the midpoint, or the point halfway between 2 points on the xy plane. So the midpoint of the line segment with endpoints x1 and y1 and x2 and y2 in the xy plane is given by this ordered pair here. x1 plus x2 over 2, comma, y1 plus y2 over 2. So let's try it out. Find the distance in the xy plane between the 2 points. Negative 2, or 2 comma negative 2, and 5 comma 2. Well, remember the distance formula. We're interested in the square root of x2 minus x1, so here's x2, minus x1 squared, plus y2 minus y1, that's minus a negative 2 like that, squared. Well, 5 minus 2 is 3, so that's 3 squared, plus 2 minus a negative is like 2 plus 2, so plus 4 squared. That's equal to the square root of 9 plus 16. 9 plus 16 is 25, so we're interested in the square root of 25, which is equal to 5. So the distance between the 2 points, 2 comma negative 2 and 5 comma 2, is 5. How about this one? These 2 points are a little trickier. We're dealing with fractions. We have 2/5, comma 3/10, and negative 1/10, comma 4/5. Now the distance formula works just as well with fractions as it does with whole numbers. So let's look at this. We have the point 2/5, comma 3/10, and the point negative 1/10, comma 4/5. The distance formula still works. We're interested in the square root of x2 minus x1, so negative 1/10 minus 2/5 squared plus y2 minus y1, 3/10 squared. Well, 2/5 is the same as 4/10. So we have negative 1/10 minus 4/10 squared plus 4/5 is the same as 8/10. So that's 8/10 minus 3/10 squared. Well, negative 1/10 minus 4/10, that's negative 5/10 squared still, plus 8/10 minus 3/10, that's 5/10, still squared. Well, this right here you should see pretty immediately. Negative 5/10 is the same as negative 1/2, and we're squaring it, plus 5/10 is positive 1/2 squared. So 1/2 squared plus 1/2 squared, that's going to be 1/4 plus 1/4, or the square root of 1/2. Now generally in math we don't like to leave square root of 1/2 around because that's leaving a square root in the denominator, and that's a bad habit. So let's reduce it down some. Square root of 1/2 is the square root of 1 over the square root of 2, which is 1 over the square root of 2. The way we remove the square root from the bottom is to multiply top and bottom by the square root of 2. So 1 over square root of 2 times square root of 2 over the square root of 2. This number here is just 1. Anything divided by itself is 1. And if we multiply 1 to some number, we just get that number again. So this is legal. Multiply it this way, and you get the square root of 2 over 2. Square root of 2 times square root of 2 is 2. So the distance between these 2 points is square root of 2 over 2. All right. So now let's try a problem using the midpoint formula. I've written one out for us here to look at. We want to find the midpoint of the line segment connecting the points square root of 2, comma square root of 5, and square root of 2, comma negative square root of 5. Remember, to find the midpoints, we add x1 and x2 and divide by 2. So that's square root of 2 plus square root of 2 over 2. Square root of 2 plus square root of 2 over 2. That's the x. And y is y1 plus y2 over 2, so square root of 5 plus negative square root of 5 over 2. And that reduces to square root of 2 comma 0. Square root of 2 plus square root of 2 is 2 times the square root of 2. The 2's cancel out, leaving us just the square root of 2. And then positive square root of 5 plus negative square root of 5 is just 0. 0 over 2 is 0. So the midpoint between these two line segments is square root of 2 comma 0. Now it's your turn to try a problem. Go ahead and pause the video and give this problem a try, then come back and we'll work it together. Find the midpoint of the line segment connecting the points a plus b comma a minus b and a minus b comma b minus a. All right, well, how did that go? Remember, we add the x values together. So we have a plus b plus a minus b all over 2, comma, now we add the y values together. A minus b plus b minus a all over 2. All right, well, here's a positive a and a positive a. We're adding those together. So we're going to get 2 a's. Here's a plus b and a minus b. So the b is going to cancel. So we have 2a over 2, or just a. Here we have positive a and minus a, so those will cancel out. And negative b and positive b, so those cancel out. So we have 0 over 2, or just 0. So the midpoint here is a comma 0. So let's try an application problem involving these skills. Use the midpoint formula to complete the following. The average life expectancy of a female born in 1980 was 77.4 years, and for a female born in 2000 was 79.5 years. Estimate the average life expectancy of a female born in 1990. The actual life expectancy, in case you're interested, was 78.8 years. All right, so how are we going to do that? Well, first, we have 2 points, if you think about it. In 1980, the life expectancy was 77.4 years. In 2000, the life expectancy was 79.5 years. So these are our 2 points. Now what we're going to do is find the midpoint. Remember, add the x's, 1980 and then 2000 all over 2, comma, now add the y's, 77.4 plus 79.5 all over 2. That gives us 3,980 over 2, comma, 156.9 over 2. Now, this certainly turns into, when you do your division, 1990, which is the year we're looking for, and 78.45. So the average life expectancy of a female born in 1990 was 78.45 years. In this lesson, we've worked with data. We've been sure to do we've done lots of exercises about distance formulas and midpoint formulas. And there are a lot of lessons like these in your book. So give those a try before you come back next time and we do a new lesson.